In this video on 1.1 Systems Architecture, we're going to examine the von Neumann architecture. The von Neumann architecture is the work of mathematician and scientist John von Neumann, who pretty much invented computing. And he came up with the idea of this architecture that had the following components in it. And we can see here that it specifies it must have a processing unit, a CPU, with an ALU and some registers. It must have a control unit, which has a program counter in it. It must have some form of memory to store data instructions for the programs it's running. It must have some form of external mass storage for programs when they're not being used, and some form of input and output mechanisms. So let's take this idea and examine it in more detail. So here's our diagram of a von Neumann machine, which we've taken from the Wikipedia article you just saw. And you can see that it specifies there's got to be some kind of input device, which means some kind of keyboard, mouse or touchscreen in today's computing. Some kind of output device, again, some kind of screen, some kind of sound. And then we've got this central processing unit in the middle, which is pretty much the entire computer. Inside that CPU, there is a control unit which controls the actions of the CPU when it's fetching, decoding and executing instructions. And it also has an arithmetic and logic unit which is responsible for carrying out the actual instructions. Connected to that is this thing called a memory unit, which is also known as RAM in modern computers, and it's connected by these arrows which are called buses. So you can see that the specification wants us to discuss specifically these registers, the MAR, the MDR, the program counter and the accumulator. And it would also make sense to discuss the ALU and the control unit at the same time. So if you watched the first video in the series, you'll know that the job of the CPU is to carry out program instructions. It fetches those from RAM, which is where they're stored when the program is running, and it carries them out one by fetching, decoding, working out what the instruction means, and then carrying it out before returning the result to memory. The MAR, MDR, program counter and accumulator are all registers, and all a register is a single fixed piece of memory which has a specific job inside the CPU. And it would make sense to start with the program counter. The program counter is the most important register in a von Neumann architecture computer, and indeed in modern computers. The program counter holds the address of the next instruction to be executed. In other words, it is the next instruction we need to get from the current program we're running. Also, if we want to change the program we're running, so multitasking when you switch between tasks, you just change the value in the program counter to point to the next instruction of the next program you want to run. So the program counter really does keep track of what the CPU is doing and indeed what it's doing next. The program counter is incremented each time the fetch, decode, execute cycle goes round, and it's either incremented by a set amount to go to the next instruction, or if the program has jumped somewhere else or is looping around, then it will change by a different amount. Don't forget that an address is simply a number which relates to a memory location in RAM. If you imagine RAM as a series of boxes and each box has a number into which you can put one program instruction or one piece of data, then it makes it easy to understand. When the program counter is incremented, we copy the contents of the program counter to the memory address register. And the memory address register simply holds the address in RAM that we are about to either fetch something from or store something in. The CPU is connected to RAM via the data bus and the address bus. The memory address register specifically is connected to the address bus, which makes sense being as it's the address register. The contents of that address register are sent down the address bus to RAM, and you don't need to worry at GCSE how that's dealt with. Just know that when the memory receives that address, there has been a control signal sent down the control bus by the control unit, which tells it whether it's fetching or whether it's storing data. The memory is connected to the CPU by the data bus, as we've previously mentioned, and the memory data register is the register that's connected to that bus, and it holds the data that we have just fetched from RAM or we're about to store in RAM. It's the job of the control unit to decode the instruction and work out what the CPU is actually being asked to do. Once the instruction's been decoded, it's then passed on to the ALU, which is a complex series of circuits which are designed to carry out arithmetic and logic instructions, of which most of a CPU instruction set is. So the vast majority of CPU instructions will be actually executed in the arithmetic and logic unit. Finally, once the instruction's been carried out and executed, the result needs to be stored somewhere, and that's often in a special register called the accumulator. And the job of the accumulator in the exam, you simply need to say it holds the results of program execution or instruction execution. The thing that keeps this all together is this idea of a control unit here, and it communicates with the various parts of the CPU, but also external components through something called I/O, input-output, and all this communication takes place down the control bus. In the exam you may be asked what the function of this control unit is, and you can simply say that its job is to coordinate how the CPU works, and give examples such as sending a signal to RAM to tell it whether to read or write, incrementing the program counter, or indeed even decoding program instructions. So simply, the von Neumann architecture is the architecture on which most modern computers are built. What you need to know about the von Neumann architecture is that it consists of input devices and output devices, but specifically a central processing unit which contains a control unit, an ALU, and some special registers. That CPU is connected to a memory unit, as it says in this diagram, or RAM, as you will talk about in your exam, which holds the program and instructions that we are currently executing. All data travels down buses between the CPU and the RAM, and indeed any input and output devices. The buses that you need to know about are the address bus, the control bus, and the data bus. And they're connected to these registers that we've looked at here. And to recap those, the program counter is the most important register, as it tells the CPU what it's doing next. It holds the address of the next instruction to be executed. This is copied to the memory address register, which holds the address we're about to fetch from in RAM or store to in RAM. The memory data register is connected to the data bus and holds the data that we've just fetched from RAM or are going to send to RAM. The ALU actually carries out the instruction once it's been decoded, and the accumulator holds the result of that calculation. In the next video we'll have a look in detail at how that fetch decode execute cycle works.